So sorry. Thank you, Michaela. Yeah, so we're talking about topic 1, graphical displays, and we just to kind of recap what I forgot to record. We were talking about in terms of these graphs, which graphs would be used to compare distributions, and we said box plots and stem plots would be 2 ways to compare. One thing we said about box plots is it's very important to make sure that they're on the same scale. So you could put the scale in the middle, graph one above, one below. That would be an easy way to do it. You can also graph them both above. It doesn't really matter as long as they're on the same scale. Stem plots are fine as long as they are used for small samples. We are going to look at words in terms of vocabulary when we look at graphical displays, things like clusters, gaps. Those are things that we deal with shapes. What is the acronym that we use when we talk about describing a distribution? Do you remember? SOX, okay? So when we're looking at describing a distribution, remind me what each of those things stands for. Shape, okay? Shape, outliers. I'm going to include gaps in here, okay? And then what is C? Center, and then spread. Good. Okay. So whenever you're asked to compare distributions, I keep going back to that because that's often what you'll see. You need to make sure you graph an appropriate display, and often they'll use those exact words. Graph an appropriate display to compare distributions. And so this would be appropriate when you are comparing. And then this is, you're going to address shape, outliers, and gaps. Clusters can be considered there when they're grouped together, center and spread. What are some key words for shape? Let's just kind of remind ourselves when we do. What are some descriptors for shape? Unimodal, sure. I'm just going to write a whole bunch of words down. You guys just kind of yell them out to me in terms of vocabulary. Unimodal, give me something else. Skew what? It's important to tell me the direction of the skew, okay? So skew left or right. Give me something else, just yell them out. Uniform, different than unimodal, very much so. Make sure we know what uniform means. Keep going. Symmetric. Symmetric doesn't necessarily mean unimodal, by the way. You can have symmetric with 2 peaks. You can have a bimodal symmetric distribution. So be careful that you know that these 2 things are different. Give me some other words. I just said it, right? So bimodal, multimodal just means the number of peaks that you see in the graph if we're looking at a histogram in particular. I think that's about right in terms of shape. How about outliers and gaps? You would tell me where the outlier would occur, or maybe where there were gaps in the data. What are some graphical displays that show gaps? Box plots do not show gaps at all. That's important to understand. Box plots do not show gaps. What does show a gap? Histograms do. Stem plots do. Those are the only ones, okay? So if you are trying to graph an appropriate display that shows a gap, it's important to know which ones to pick, okay? You want to be able to graph. Why doesn't a stem plot show a gap? What does a stem plot show? The outlier, right? It shows the outlier with a little dot. So it'll show an outlier, but not necessarily a gap, okay? What did I say? I meant box plots. Yeah. Sorry. So what I mean is this. So a box plot can show you if there's an outlier, right? Whereas a histogram might show you where there's a true gap, okay? So this is different between an outlier and a gap. And they're so, by the way, Maeve and Nick, I just write the type of data display that you might see, data display, different thing, the type of sampling that you see there. Okay, thank you. So outliers and gaps, so we're just trying to figure out the difference between it. And again, AP is so particular about, they're not particular is my point. You choose the appropriate display, and so part of the grading rubric on these questions would be that you chose the right kind, okay? All of these graphical displays that you see written here talk about, well, that we've talked about so far, deal with what kind of data? Qualitative or quantitative? Quantitative, right? The only one that deals with qualitative up here would be a bar chart, right? A bar chart does show, bar graph, I think is what we typically call it, or a pie chart. Pie charts aren't really often used. Bar graphs are used for counted or categorical, qualitative, all same words, data. What is a segmented bar graph? What does it show? Okay, when it stacks is what it looks like. So a segmented bar graph. When it stacks, it might look like, I don't know. Okay, keep talking, Mason. You're making me happy. Say it again. Yeah, so you would see percentages in here, right? So what kind of so it shows what kind of distributions, conditional distributions, right? So we're looking at, oftentimes we'll be comparing to, well, you'll have two different bar charts and you'll be looking to see if possibly that they're the same, right? Does this look semi-familiar to you? You're like comparing the two distributions in a segmented bar graph and you're trying to see whether or not they're similar or different. Oftentimes you'll see, like Mason suggested, the percentages inside the bar graph. So and they should all add up to 100%, right? So I'm just going to make up numbers. We'll say 25, we'll say 5. I don't know, I'm making up, how many is that now? So that would be 10, right? I don't know. So that kind of idea, you're comparing. Again, this is qualitative data. We're looking at categories. Each of those is a particular category, often shown to compare distributions in the qualitative sense. Okay, what other what other graphs do we talk about here? How about cumulative frequency plots? What are those? You guys done? Thank you, thank you. Cumulative frequency plots. Another word is an ogive. It's kind of funny, kind of fun word to say. It's my favorite word, actually, in all of statistics is ogive. I just want to write it because it makes me happy. Ogive. I feel like it's a dance, but it's not. What is it? I'm scared. Y'all are quiet. What's an ogive? I'm afraid of you. All right, well, we'll talk about one today. It's typically S-shaped, right? And it shows the data or the distribution cumulatively in nature. Over time, it shows at the end, it's 100%. The whole data is distributed. You add as you go. We'll look, and often we use them to find like quartiles and things of data, but we'll look at those in a few minutes. All right, so let's just jump into a question. So read this question. I'm going to turn the lights down so you can see it. And let's see what we would do. Ooh, all the words that you see are what kind of words? Shape words. Okay, good. So if I'm trying to figure out the shape of this, what would I do to figure out the shape? You have calculators in your hands? If you don't, you should get one. Now that you have calculators, what's the thing I want to do to be able to determine the shape of this distribution? What kind of graphical display would allow me to see the shape? Y'all are scaring me. If you did a histogram on the calculator, it may or may not give you a nice shape. You can try, okay? But the way that the algorithm that the calculator uses to come up with those bins or classes or the widths of those particular bars in the histogram is kind of a complicated nightmare. And so it's not real pretty. There is a way to adjust it, but I never really showed you that. I might start with a box plot first just to see if it's really skewed heavily, but that's just me. The calculator's best graph is a box plot. What do you guys get? Are you still entering? All right, I'll wait a second, then I'll be quiet. So we had to add that 670 in there in order for it to make it a 20 student scores. So, sorry, just add that 670 in there. So you should get a heavily skewed left distribution when you graph it, and the box plot shows that pretty well. I think, is it a long whisker that you get, or is it a long box that you get? Should be a long whisker, right? So heavily skewed to the left. Very good. And again, skewness is in the tail, right? So that tells you the direction. Good. All right, let's try a second one. I'll pause the recording while you read this one. Oh, and by the way, this is number 1, number 2, and number 3. It is my understanding that AP has come and gone away from, and SAT too, by the way, for those of you who've recently taken the SAT, let me know. This format of kind of multiple choice question used to be extremely common. I think they've since gone away from this 1, 1, 2, 1, 2, 3 kind of a question. Is that true? You guys tell me. Have you seen them a couple times still? Okay. So I only have what AP is released to me, and so I can go by what my students have told me that they saw in the exam, and then, although that's after the scores come out, of course, it is. And then what is released and what's in the practice exams. What's been released in the practice multiple choice questions are often this format of choosing one or multiple parts to be true. We'll see if that format continues. They're still in the released part. They're still in the practice problems that are given to us by guides. But you'll see this format quite a bit in practice. I'm not sure what happens in reality. What do you guys think about this one? You think it's only for number 3? Okay. First of all, is there any one graph that's useful for both quantitative and qualitative data? Not at all, right? It's your one or the other. So we can just cross that one off because it doesn't make sense. You have to have one or the other kind of data. You can't have both. All right, how about number 2? We just addressed that with stem plots, didn't we? Only useful for what size? Small, very good. So we're either at 3 or none. We don't have a none, so we know we have to be 3. Sometimes a none exists. But stem plots do show symmetry, gaps, clusters, and outliers. So good, I agree. Excellent. All right, how about this one? And again, Roman numeral 1, 2, and 3. All right, so I agree that C is the correct answer. So if you got that, that's good. I think Roman numeral 2 is distracting. If 2 and 3 was an answer choice, would you have chosen it? Okay, I hope not. I think the inference unit, because we're always looking for unimodal and symmetric, and we always say it's relatively normal, so often is one of the conditions that second bullet point is a little misleading, okay? Just because you're symmetric, unimodal, and bell-shaped doesn't mean you're always normal. Give me another distribution that we know of that's unimodal and symmetric. T distributions, right? And T's aren't normal. The higher degree of freedom you have, the more normal it gets. But if you have a very small degree of freedom, it's not normal at all. It has those big fat tails, right? So we just have to be careful of that. All right, I think that one's kind of a misleading one. All right, so that was graphical. We're going to get to other kinds of graphical displays as well, but let's keep going here. We're going to talk specifically about mean and median, the spread. So we're talking about our center and our spread. Something that we didn't hit a lot was measuring position. Okay, we're talking about percentiles. But z-scores we definitely hit. That's a position in a normal distribution. Empirical rule deals again with normal distributions. Histograms versus cumulative frequency, looking at those in terms of measures of spread as well. So let's go through it. Maybe at least one question on this before we have to stop here. So what do you think about this example? And again, this is page 67, number 1 in your text, in your review guide. I see nobody with their calculator, which I find very interesting because this is definitely a calculator question. Just because it has all words doesn't imply that you shouldn't. So we have 10 players who went hitless, which means I'm going to enter how many zeros in my calculator, okay? And then we have 8 ones, and then we have 1 3. So if I'm going to write down, I'm going to write it down literally like this. We're going to have how many was 8, 4? That's going to be the numbers. Would you agree? And you're literally just going to find the mean and median.